Here we're going to look at question 14 from section 2 of the ENGAA specimen paper. So in this question, we're told we have a ray of light which is being beamed upon this transparent block which has a refractive index of n. And the angle of incidence of the beam of light is going to be 60 degrees. Then it's going to travel vertically 5 centimetres and horizontally 2.5 centimetres before emerging out of the other side of the block back into air, which is just going to have a refractive index of 1. So with this information, the question asks us to find n, the refractive index of our block. Now if you'd like to have a go at this question yourself, then please pause the video now, otherwise let's have a go. Okay, so to try and think about solving this question, we should think about which equations we can use to try and do that. Now since we're being told about a light ray which is refracting, and we're trying to find the refractive index, there's one law which should probably spring to mind, and that is Snell's law. So Snell's law mathematically is given by this, that the refractive index of the first material multiplied by the sine of the incident angle is equal to the refractive index of the second angle multiplied by the sine of the refracted angle. Now why is that going to be useful in this case? Well, shall we see if we can try and plug in some values from before, or from this scenario. So we know the refractive index of the first material is just the refractive index of air, and we know the incident angle is just 60 degrees, so the left hand side of the equation is going to be this. Now if we look at the right hand side of the equation, our refractive index is just going to be n, the refractive index that we're trying to find, and then the refracted angle is just an angle which I've labelled on here as theta. Now obviously we don't know what theta is, but let's see if we can try and find it some way, and then we should have an equation we can try and find n. Before we do that though, we can just simplify this equation a little bit, since we know that n0 is just 1, and sine of 60 degrees is root 3 over 2, giving us this. So finding theta is going to be really nice and, we'll make it really nice and easy just to find out what n is. So to find sine of theta, the easiest thing to do is probably going to be just to try and find theta. So let's think about how we could do that. Well, on our diagram, we've been given some lengths. This length here, 2.5 centimetres, and this one here of 5 centimetres. So maybe we should try and use that, since they're going to make up this triangle here, which has this angle theta inside it. So I'm going to draw that just below here. And let's see if we can use some trigonometry to try and find out what theta is. So the standard thing to do in this case would probably be to try and just find tan theta, because it's just going to be the opposite here divided by the adjacent here. Now if we do that, we're going to find that just tan theta is a half. But what now? Because if we try and do this, then we find that actually there's no easy value for theta from this. So this seems like a bit of a dead end. What we could try and do instead is find sine theta directly. But how are we going to go about doing that? Well, sine theta is just the opposite, which is our 2.5 centimetres, divided by the hypotenuse. But we don't know the hypotenuse, although we could try and work it out, because we have a right angle triangle and both of the other sides. So with a bit of Pythagoras, then we can go ahead and solve this to get that the hypotenuse is just going to be 5 root 5 divided by 2. Then with this, it makes it quite easy to try and find what sine of theta is going to be. We can just go ahead and take the opposite, our 2.5 centimetres, and divide it by our 5 root 5 over 2 centimetres. Then noticing that 5 over 2 is just 2.5, they're going to cancel, so we find that sine theta is just equal to 1 over root 5. Now with this value, we can just go ahead and substitute it back into our equation that we found earlier for n. So doing this on a nice new page, we know that sine theta is just 1 over root 5, so plugging that in, we get this, which of course we can multiply by root 5 to get n is just equal to root 5 multiplied by root 3 over 2, which is just the same thing as root 15 over 2. So this is just going to be our final answer, the refractive index n, and it corresponds with answer H given in the question.